Hello students, let us discuss the concept of frictional force in case of translation and rotational motion. Whenever the simultaneous action is taking place like translation and rotation, what is the direction of frictional force? See, let us assume a body of round section of any arbitrary body like a ring, like a disc, like any sphere, like hollow sphere, solid sphere, any body. If a force F is applied somewhere at a distance, let us assume x, okay, and let us assume the radius of gyration is k, and the mass of this body is m. Okay, so to decide the direction of frictional force, we must have the direction of acceleration first. So here are two acceleration. One is if force F is applied in this direction, there must be a translational acceleration in this direction. Means at this point the translational acceleration in this direction, that is at. Okay, and if the force is applied here, then at this point we see the force is acting in this direction, means it is clockwise direction, means the body will go like this. Okay, so the direction of alpha, that is angular acceleration, will be in this direction. Okay, so due to this alpha, the circumference of that spherical body feel the tangential acceleration due to this torque. Let us assume that is AC. So this is translational, and let us assume this is not AC, that is AR. This is rotational due to rotation, and this is due to translation. So let us assume this point as P. Then we can say the acceleration of P equal to AT minus AR. Very simple. That is, the acceleration of the point P is given as the acceleration, translational acceleration minus rotational acceleration. See, if you apply a force F uh, on mass m, the acceleration, okay, the acceleration of the body, that is translational acceleration, it is what? F divided by m. Very simple, it is F divided by m. So next one, what is AR? For finding AR, we must have alpha. Alpha is given as, what is alpha? Alpha is torque divided by I, that is moment of inertia. Okay, so for different body, the moment of inertia will be different. So let us assume the radius of gyration is k, then we can write I equal to I, that is moment of inertia, it is equal to mk square. So what is torque? If you see about this point, that is center, and the torque is r cross f, that is x cross f. So the torque is x cross f. So xf divided by the moment of inertia, that is mk square. So if we write AR is what? R, that is the radius. This is the radius of the body into alpha. So it is x r f divided by m k square. So we can write the acceleration of point P is what? At minus a r, that is equal to, if we are taking common, f by m, and it is 1 minus x r divided by k square. Okay, so now analyzing the force, that is frictional force. Say if the acceleration of P is positive, okay, means the point is moving in the direction of AT, then frictional force will be in backward direction. Then frictional force will be in backward frictional force will be backwards. Okay, so if AP is positive, if AP is positive, then we can say that is F by M 1 minus XR divided by K square is greater than 0. That means 1 is greater than XR by K square is greater than 0. We can say K square is greater than XR. So X is what? X is less than K square by R. Okay. So, in this sense, if you apply the force at x distance, that is k square by r, that is greater than this. Okay, so if x is less than k square by r, then it is in backward direction. If x is greater than k square by r, then it will be in forward direction. Okay, I hope you understand. That is, in if r will be in forward direction. Okay, what happens and if x is k square by r? If you put x equal to k square by r, then it is 1 minus 1, that is the acceleration of p. That is, if x equal to k square by r, k square by r, then we can say the acceleration of point P equal to 0, means at equal to ac. Simply, if it is 0, then it is at equal to ar. That means there will be no frictional force. Okay, both the accelerations are balanced and the point of contact will act like imaginary center. Okay, so AP is 0 means no frictional force. So the point P will act like IC and it will start rolling. Okay, at the point of application of force. So this is your basic concept behind the direction of frictional force. It is very confusing for the JEE aspirants. It is very confusing. Whenever we think about the frictional force, many things comes in mind. So keep it simple and solve like this. You can solve any problem of the direction of frictional force. So practically, in the sense, if the defined body, in the case of defined body like ring, disc, what is the direction? So we are now going to deal with the help of these concepts. Okay, so start with, if the body is a ring, the very simple, take a question that is that is, if a ring is kept at a surface and a force applied at distance r by 2. So tell me the direction of frictional force. Very simple, very basic question. What is this? This is a ring, and we know I of ring is what? mr square. So what is translational acceleration? First find the steps are, the first find at. At is what? F divided by m. Okay, then find AC. AC is what? Alpha into R. So what is alpha? Alpha is tau divided by I. That is torque divided by moment of inertia. So torque, what is torque? So it is torque divided by I, that is moment of inertia, into R. So what is torque for this force? Yeah, that is F into R by 2, and this R followed divided by I, that is M R square. So this is R square is cancelled by these two. So F by 2M. So clearly we can say AT is F by M and AC is F by 2M. Very straight answer. That is, this is AC is half of AT. Okay, so we can say the AT is greater than AC. If AT is greater than AC, that means the acceleration of point P will be positive. Yes or no? Yes. If the acceleration in this direction, the acceleration is in this direction, means the and we know the frictional force opposes the relative motion. Okay, so this point will try to move in this direction, but friction force will oppose in backward direction. So we can say the friction in backward direction. Okay, so next, if this body is a disk, so let us solve. If this body is a disk, then what is the direction of frictional force? Okay, so let me calculate before making any assumption, just to calculate for understanding purpose. So let us assume if it is a ring, so okay, it is a disk. We have already calculated for the ring. So let us assume if it is a disk of mass m, radius r, and the force is applied, at r by 2. So what will be the tangential acceleration? That is same, that is at equal to f by m. Nothing change over here. Okay, so what will be the centripetal acceleration? Sorry, my bad. What is the rotational acceleration? So this is a rotational acceleration. My bad. This is rotational acceleration. Acceleration due to rotation. Okay. So what is the acceleration due to rotation? This is alpha into r. And what is alpha? Alpha is torque divided by I into r. So what is torque? Torque is F into R by 2 divided into R, this R, divided by I. What is I? I is moment of inertia. And what is the moment of inertia for the disk? That is mr square by 2. So it is m r square divided by 2. So 2 cancel out, and this is r square cancel out. So it is F by m. So we can say the AR is equal to AT. That means AP will be 0. So no relative acceleration of the point P, so there will be no frictional force. Very simple. So it is what? No frictional force at point P. This point P. We can apply these concept over some other body like a sphere. Also we can apply for the sphere. Let us assume this is a sphere. Force is applied r by 2 distance. Okay, so if r by then at will be same f divided by m. So let us, all the conditions are same, mass, radius, r. So f by m is what? Your tangential acceleration. And what is ar is equal to alpha into r. So alpha is torque divided by I into r. So what is torque is same, f r by 2 into r divided by what is the moment of inertia for solid sphere. Let us assume this is solid sphere. It is 2 by 5 into amr square. Okay, so r square is cancel out. Then it is 5f divided by 5f divided by 4. This to 4m. Okay, so we can clearly say what is AC. What is 80? 80 is F by M, and it is 5 by 4, means 1.25 something. Okay, so if 1.25 means AR is greater than 80, and 80 is less than AR. AR is greater means this direction force is acceleration is greater. Okay, so we can say what is AP? AP will be negative. Simply AP will be negative. If AP is negative, if AP is negative means it is backward, then frictional force will be in forward direction. So friction will be in forward direction. So in case if it is hollow sphere, so if in case it is hollow sphere, and then AT will be remain same. And what is AR? AR for hollow sphere. If hollow sphere is considered, then air will be alpha into r. Then it is torque divided by r into r, which is equal to what is torque? Torque is f r, sorry, f r by 2 into r divided by the moment of inertia of hollow sphere is 2 by 3 mr square. Okay, so it is 2 by 3 mr square. So r square is cancelled out. So it is 3 by 4 f divided by m. So here we can see clearly that is AR air is what, 3 by 4, that means it is 0.75 F by m, which is less than 80. In this case 80 is greater than air, then we can say the acceleration of p is in positive direction, so friction will be in backward direction. Okay, so this is the basic concept behind the frictional force, as you see, and I hope you understood well. So if you have any doubts in random topics, you can comment. Okay, so thank you, keep reading, bye bye.